Hello, welcome to this Gespie's Atari stuff video. It is now, during recording of this video, summer in Europe. In recent years this meant no new videos for this channel. In the Atari world everything is a bit quiet, not much news is released. And because you go out more often in the summer, there's less time for do-it-yourself projects. So during this period the channel is taking a break. But this summer it will be different. This summer it will be the summer of the Atari ST. I have not done much with this Atari series for this channel, but with acquiring of the 520 ST a few weeks ago, it has gotten renewed attention. In the previous video we gave the 520 ST a fresh look with a retro bright treatment, and in this video we will look at the different ways to connect the ST to an LCD monitor. If you saw my previous video about restoring the Atari ST, you would have seen that I have connected it to an LCD screen with an RF cable. Sufficient to confirm that the ST was working, but yeah, the image quality leaves much to be desired. But there are methods to get a better quality image. There are various cables and converters for sale, but especially if you live outside the US, they are a bit harder to come by. But of course you can also make them yourself, and that's exactly what we will do in this video. When you bought an Atari ST during its release period, you could choose whether to buy it with the Atari black and white monitor or the color monitor. Both monitors had a fixed video cable with a 30-pin DIN connector at the end, which you could connect to the Atari ST. No need to worry about different cabling. But if you want to connect the ST to a modern screen now, you have to figure out a few things. On one side of the cable the 30-pin DIN connector, but what comes on the other side? And that depends on which monitor you have and whether you want to use color or the high resolution black and white. But let's start with color. Then it is easiest if you have a monitor that has a Scart connection. The frequency of the color signal is quite low. That is based on the TV system of that time. And most modern monitors cannot handle that. But they can if they have a Scart connection, because Scart is mainly intended for TV signals. There are several 13-pin Atari ST2 Scart cables available online. But this largely depends on where you are situated. You can also make such a cable yourself, and that is what I chose to do. Of course you need a 30-pin DIN connector. Fortunately I was able to find this online. Then we go online to look for a diagram. There are several, but I found this one the most convenient. Here we see the three color signals for green, blue and red. Between them there are 75 ohm resistors. They are optional, but without them the image could be too bright. I don't have any 75 ohm resistors at the moment, so I'm using 68 ohms. We start with the 13-pin DIN connector. That's quite a lot of pins in a small area, so it's a bit trickier to solder. That's why I'm starting with the pins in the middle, because they will be harder to reach later. I also put a heatsink over each solder joint to keep them from touching each other. And this is what it looks like after the two middle pins are done. Then the other pins can be soldered and then it looks like this. To ensure the soldering is correct, I test them with a multimeter. I first check if the pin itself is connected, and then I check if it's not making contact with the surrounding pins. Then the connector can go in its case. To be sure, I put a piece of electric tape over it. It's all a bit tight with all those wires, but it just fits. Then the plastic sleeve can go on top, which also keeps the connector in place. And then this side of the cable is finished. Now we'll do the side with the Scart connector. We see here that the ground connections for all signals are connected to each other. I'm going to solder these first. For that I solder shorts between the connection pins. And that looks like this. Then we solder the resistors for the R, G and B signals. Then the signal wires go to the other ends. A heat shrink tube goes over that as well. Then the audio signal. A mono signal comes out of the ST, but the Scart connector has a stereo connection. The mono signal is therefore connected to both left and right connections. And the other signals can then be connected. With the VGA signal we see that there are a diode in between plus a capacitor to the ground. We start by placing the capacitor. And the diode goes on top of that. And the V signal itself goes to the other end. With another heat shrink tube, of course. As last I connect the ground signal. This signal is connected to the cable's shielding. Now all the signals are connected to the Scart connector. But the ground signal should also be connected to that metal cap that covers the pins. The connector can now be placed in its housing. It's quite spacious, but with all those components it still will be a bit tight. But it fits in the end. And with that the cable is finished. And now we can start testing it. We can remove the RF cable now. Well, let's see how much better the image is compared to the RF cable. Whoa, that's much better. What a difference. Let's see what this looks like with medium resolution. Yes, now the text is much easier to read. I'm going to start sysinfo. That was almost impossible to read with that RF cable. Ah, much better. It's just very readable now. And now we look at the monochrome high resolution signal. This signal has a higher frequency, so it cannot be displayed via the Scart connection. For this we use the VGA connection on a monitor. And here's the diagram for the monochrome signal cable. The monochrome signal comes from pin 11 on the 13-pin DIN connector. We connect this to the R, G and B pins of the 15-pin D-sub VGA connector. We also insert the 75 ohm resistors there. To ensure that the Atari ST boots in monochrome mode, there's a monochrome detect connection on pin 4. To get a monochrome signal, we connect this pin to the ground. But the VGA connection doesn't have an audio input connection. For this we can connect the ST audio output to a 3.5 jack connection. You can then connect your speakers or headphones to this. But anyway, we have two different cables. Can we also use the VGA connection for the color signal? Unfortunately, that's not possible. The frequency of the color signal is too low for a VGA connection. Unless you have a so-called multisync monitor. NEC in particular is known for its multisync monitors. To connect such a monitor there are ST to VGA converters available. You plug this directly into the monitor connection of the ST. And the other end you can connect a standard VGA cable. And you will connect the speakers to the jack connector. There is a small switch on the adapter. This switches between color and monochrome mode. Now, I used to have a Multisync CRT monitor. And I use this cable for that. The switch on the box is used to switch between the color and monochrome. On this side is the 30-pin DIN connector for the Atari ST. But on this side there is a 9-pin D-sub connector. This went straight into the Multisync CRT monitor. But now I have this NEC Multisync LCD monitor. And that has simply the standard 50-pin D-sub VGA connector. To connect the 9-pin connector to the 15-pin connector of the monitor, I need to know the pin assignment of this 9-pin connector. And I can't find that anywhere. So I have to open it to find out how it's connected. Luckily the box is easy to open with 4 screws. Okay, so this IC takes care of the switching. It must be a multiplexer demultiplexer. I'll look up that model number. And indeed, it's an MUX demux. And here we see the pin assignment. If we look a little further, you'll see that it has 4 outputs. And these are connected to these 8 inputs based on this control signal. Now I need to know how the wires are connected to the 13-pin connector. For this I'll open the connector. And then I make a list of the 13 connections. Now that I know which colors go to which pins of the ST connector, I write down where they are connected in the box. We start again with pin 1, the white wire. Okay, that goes to the audio output. And so we will go to all the colors. So that's the last one. With this list we can now draw a diagram using the MUX datasheet. I've already made a start here. On the left are the 13 pins of the ST connector. And in the middle I've drawn the MUX schematic. With the 4 switches, X, Y and Z and W. Each switch has 2 input or outputs. And they are all controlled by this control signal. It determines whether X0 is connected to X or whether X1 is connected to it. Furthermore, there are pins for the IC's power supply. And a switch and the audio connector. The VGA output will be located below that later. I start with pin 1 again. This goes to the audio output. Pin 2 is for a composite video, we don't use that now. Pin 3 is a general purpose output. This is applied here to apply 5 volts to the control signal. Then we have pin 4, which is the monochrome detector. This is connected to one of the outputs of switch W. Then we have audio input, we don't use that. And then the first video signal for the green color. This is connected to one of the inputs of the first switch, X. Next we have red, which is connected to the second switch, Y. Then we have the positive 12 volt output. This is used to power the IC. The horizontal sync. That goes directly to the horizontal sync of the D-sub connector. Then we have the blue signal. That, of course, goes to the third switch, Z. And then we have the monochrome video signal. That will probably go to the other inputs. And indeed, it's connected to the other inputs of the 3 switches. It's a bit of a mess now, just a bit of tidying up. There, that's better. Then the vertical sync, which is also directly connected to the output. Then this leaves us the ground connection. This is connected to a lot of things. First, of course, to the ground of the IC. And it is also connected to the ground of the audio signal. But ground is also connected to the input of switch W to generate the monochrome detection signal. Now that we know the inputs of the MUX, we can also determine what the outputs are for. For example, pin 4 of switch X produces the signal for the green color. Pin 5 does the same for the red signal, and pin 13 for the blue signal. So, pins 4, 5 and 13 need to be connected to the RGB pins of the VGA connector, and the V and H sync to the corresponding VGA connections. For this, I have now drawn the 15 pins of the VGA connector. The pins in the middle are for the ground, and they are all connected together. We can now draw the remaining signals. And now we have the complete schematic. You now have a diagram if you want to build one yourself. Now we know which colors goes to which VGA connection, we can replace this 9-pin D-sub connector with a 15-pin D-sub connector. But I'd rather leave this connector as is. That's why I did something different. I made this adapter cable with a 9-pin D-sub on one end and a 50-pin D-sub on the other. I then connect the 9-pin connector to the connector on the ST cable. And then this side can go into the VGA connector of the monitor. Now we can finally test everything. I've now connected the cable to my 520 ST and this to the Multisync monitor. The switch is set to monochrome. Now I'm going to turn on the ST. Yes, we have a picture. But also a lot of bending. Let's see if we can do anything about this with the settings. Hey, look, if we change the width of the image, the bending also changes. So with this white, the bending is almost gone. But how much of the image I have lost now? You can see that the scroll bar on the right is disappeared. Let's see if the image can be shifted to the left. Oh wow, it just fits. Now move it down a bit. It's a shame the vertical size cannot be changed. There are still some stripes, but it's doable. Now let's see what the color image looks like. Oh, I think it was a bit better with this monitor, with the Scart cable. But it's okay. Let's check the mid resolution. That's okay too. It's easy to read. Let's also take a look what the monochrome image looks like on this monitor. This isn't a multisync, but probably it can handle the frequency of the monochrome signal. And yes, it's showing an image. Well, yeah, with the same bending problems. Can something be done about that with the settings? I can make it wider, but probably it won't fit anymore. Let's see how far to the left it can go. Well, not much. It doesn't really improve things. And I also want to see what it does with the color signal. Something is coming. Ah, indeed, it says not supported. So with these cables you can connect the Atari ST to an LCD monitor. The image isn't always of good quality. Is there anything you can do about it? Yes, you can. You can use an upscaler. An upscaler scales the signal up so it meets the level required for transmission via HDMI. The most commonly used upscaler for Atari ST is the OSC, which stands for Open Source Scan Converter. It's open source, so you could build one yourself. But many ready-made models are also available online. They'll cost you over $100, but you get a better quality than with only a cable. And if you really want the best quality, you also could buy the retrocomputer. But that's also considerably more expensive. So, now we've seen all the different ways to connect an Atari ST to an LCD monitor. If you really want good quality, an upscaler is a good option. But for a lower budget you can also make a cable yourself, if you already have the right monitor. There is actually another option. If you have a Mecha XT, then there are also graphics cards available that can connect to the Mecha bus or VME bus. These allow you even higher resolutions. However, these cards are difficult to find. And now we've reached the end of this video. If you watch the video until this point, please also click the like button. And if you subscribe to this channel, you make yourself and me happy. For now I say thanks for watching and until the next Atari stuff video. Bye!